Okay, so inshallah today's session will be super exciting and super important. I'll be introducing a new topic, so I'll try to grasp and really stay focused, try to understand as much as you can. Then you will go to the lab, you will practice some of what I will be covering today, and then you come back next session inshallah, and I will clarify if there are any gaps. Okay, so the topic is all about Kotlin coroutines to be for synchronous and concurrent programming. So first of all, what we will be covering here is I'll be covering some coroutine basics and then introduce the coroutine programming model. I think flow, I will leave it for next session, inshallah. Okay, so first of all, some basic concept review of what we have seen last time.
Doctor,
Yes, please.
can you share the screen?
Reshare the screen. I did. So let me. Okay, so let me reshare it. Okay, so as we seen last time, when we are running our app, the app or the UI is running on the main thread, and it is critical to guarantee a great user experience. It is essential to avoid blocking the main thread, as it is used to handle the UI updates and UI events. And as we saw last session, and when we try to run some heavy computation on the main thread, what happened to our app? If you recall, it was basically blocked and it was not responding. So if you run something heavy on the main thread, your app will block and your users will be confused and frustrated. So what type of long-running tasks we're talking about? So this long-running task could be, for example, processing a large JSON file or writing to a database or fetching some data from the network, from a remote server, or executing some compute-intensive tasks. So if you do these tasks on the main thread, your main thread will be blocked. During this period, while this long-running task is executing, your UI or your user interface or your app will be freezed. So any synchronous long-running task will basically block the main thread. So we need a solution for this, and we have seen one simple solution is to use multi-threading, is to basically run the heavy computation or the long-running task, run it on a separate thread, and then when the data is available, the results of the computation is available, then you go ahead and display it. Okay, so this sounds simple, but there are lots of challenging things here. We need to be able to basically run. We need to be able to pass data between threads. So between the main thread and the background thread, we should be able to transfer data between these two threads. This is not a simple task. You will see this in more details in operating system course when you go deeper into threading and how the operating system manage threads. It's a complex task to pass data between them. The other major problem is, imagine the user is using this app and they are on particular screen and they requested something that needs a long running task, and then we start the long running task on a separate thread, and then the user changed their mind and they close this screen. Now this long running task is no longer needed, and it's wasting computation, wasting battery, wasting maybe network bandwidth. What should we do to this long running task when the user closes that particular screen? What should we do to this long running task?
You should stop it.
we should stop it. We should cancel it. Thank you very much. This is important. You see, these are at least these two challenges: how to transfer data from the threads and how to cancel a long-running task when the user is no longer needs it, are very important challenges that threads are not able to easily solve. And plus, with threads are are basically costly. When you create a thread, immediately it will consume 1 to 2 MB of memory. So you cannot have many threads, and they are, especially on the server side, you cannot have many threads because they take a lot of resources. Plus, some threads are very special, such as the main UI thread. You should never block it because it blocks the UI. And the second constraint, as I showed you here, the UI can only be updated from the main thread. So if you have a background thread, you cannot touch the UI. You have to transfer the data to the main thread to be able to update the UI. So all these challenges pushed language designers such as Kotlin language to create a new abstractions and a new tricks to allow us to do this ability to basically suspend computation, suspend and resume, the ability to cancel long-running computation, the ability to run a computation outside the main thread and then resume to the main thread, and the ability to cancel a long-running task when it's no longer needed. All these challenges that I highlighted are solved by these coroutines. So coroutines is a powerful concept that were invented in the 1970s, but it took so long for them to become a mainstream. And these coroutines are only introduced in Kotlin since 2017. So it's a new additional feature that we had at our hand. As you will see, it's very, very powerful to enable us to solve this problem, of not blocking the UI, at the same time being able to communicate easily between the background threads and the main thread, and being able to cancel a long-running task, and also being able to suspend and resume. If we have a long-running task, I'll be able to suspend and then come back and resume it, suspend and come back and resume. So all these features are enabled by these coroutines. So you can think of coroutines as explained in this video. A very nice way to put it is that coroutine are basically imagine we have two construction sites. The construction site, you can think of it as the thread. So we have two construction sites, and each construction site has a lot of workers carrying out some tasks. Those workers, you can think of them as coroutines. So coroutines are much lighter than threads. You can run so many of them. They are much lighter weight, and multiple of them run on the same thread. The other things they give us the ability to cancel a long-running task, and we can also easily switch between the background thread and the main thread. We can, as you will see shortly, I will demonstrate all these features. So basically, you can do heavy tasks on the background UI thread, and then you can come back to the main thread to update the UI. And more importantly, they simplify asynchronous programming. So let me explain all these concepts through realistic examples. So here I am here. Let's start with a function that we all familiar with, such as an add function. Do we have an add function somewhere? Okay. Sorry, just a second. Where is my example? Yes, not that one. Yes, here it is. Here's my example. So what I have in this example, first of all, we all know, let's take this function add. Basically, this function add takes two parameters, x and y, and then it does the sum of the two parameters and returns the results. Very simple function. And here is the main. And you can see here in the main, what I'm doing in the main, I'm basically calling this function. Now, what happened to the main when the add is called? What will happen to the main? When I call the function, what happened to the main function? The main function
Paused.
will be blocked and waits for the results of the add to come back. So the caller function will wait for the called function to finish, get the results, and then the main function can resume. So this type of function call, it's called a blocking call or a synchronous call. You have to, the main will block. Now, this is similar to phone call. If somebody calls you, uh, you basically block. You might even stop this lecture if it's urgent, and you basically pick up that call, and then it is a blocking call. It is a synchronous way of communication. Both parties need to be there. When one of them is speaking, the other one needs to block and listen, and then they give the chance to the other party to respond. While a better way of doing it is maybe using an email or using a chat or using a messaging. In that case, do we need to block? Do we need, like when you send an email, do you block there in front of your email waiting for the reply?
No.
You don't block because the email is an asynchronous way of communication. Send the email, go ahead with your life, do other things. At certain stage, some response will come back. So you resume your email activity and you will see the response in there. So this is the shift that you need to have in your mind. So in terms of functions, we have two types of functions. Synchronous functions, when we call them, we need to block and wait for the answer to come, then we can resume our work. And there is another type of functions, we call them asynchronous functions. When we call them, do we need to block? No, we don't need to block. They are called asynchronous functions. So coroutines allows us to build these asynchronous functions. So the building block of an asynchronous function is basically what is called suspend function. So let me explain the concept of a suspend function. So the normal functions we are used to so far, since you started programming, you wrote so many functions. I am 100% sure all of them are synchronous functions. Somebody calls them, and what happened to the caller? They block. Until when? Until the function finishes execution, generates some results, and returns the results. Now, suspend function works very, very differently. You call it, it does a bit of work, and it suspends. If there is a long-running task, such as fetching some data from the network, it will not, you don't need to wait for it. It's basically suspend, that function call is suspended. You can go ahead and do other tasks, and when the results are ready, you resume the function. So there is suspend, the resume, and then at the end it will finish. So this is similar to reading a book, especially with our busy schedules. I don't think you have the luxury to sit down and just take a book and read it from cover to cover. How do you read the books typically? You basically start reading a couple of pages and then you fall asleep. And then basically you put a bookmark and you put it beside you and you have your rest. And then next day you will resume. Or maybe you have an exam, you will suspend the reading the book and then you will resume reading the book. Until at a certain stage, hopefully you finish the book. So reading the book is basically a suspend function. You start, suspend and resume, suspend and resume. And when you resume, from where do you resume? Always you start from the beginning, or you resume from where?
From the part you stopped.
From where you left off, from where you stopped. So suspend functions are so powerful, you can run them. When they come across something long running, they suspend and let you do other things. You don't need to block and wait for them. When the results are ready, they resume again and do the work, and so on. So this is the building block of coroutines, our suspend functions. So how do we create these suspend functions? So suspend function is a normal function that we're already familiar with. But they have this keyword here, suspend, in front of them. So suspend function, for example, it might do some work here. For example, I am going to get stock symbol for name. Okay, and then here I'm just simulating a network call by suspending this function for 2000 milliseconds. I'm suspending this function for 2000 milliseconds. Then after that, I do some more computation and then return from this function. I have another function here, also suspending, doing some bit of work, then suspending, then resuming later after 3000 milliseconds. So in here, I'll say symbol. And basically what I'm saying here, I am going to get price. I am going to get price, and in here I'm going to get stock symbol for name. So here, what I am simulating here, let's take a look at this. So for example, Facebook, I can go to Facebook stock price, current stock price. So basically, because Facebook is listed on stock exchange, it has a symbol called FB, and investors, they can invest by buying shares, and they can check the price. If the price goes up, like now the price is up, if they need cash, they can sell it. If the prices go down and they have money, they can buy more stocks. So we can write an app that basically converts first from name to stock symbol, and then from stock symbol to price. So there are two calls in here. Now, when I call on the web, I might call a service on the web to give me the stock symbol for Facebook. And then I'll get the stock symbol, and I do another call to the web to get the stock price, as you see here. Now, do you think it's a good idea to call these functions synchronously? Do you think it's a good idea to, when we call these functions to get the symbol and to get the price, is it a good idea to do them in a blocking fashion or in asynchronous fashion? Allahu Akbar.
Asynchronous, of course.
Asynchronous, of course. Why?
Because you might have network errors, or it might take a long time.
It might take a long time. Yes, thank you very much. Because this Nasdaq stock exchange is in US. It's busy. Maybe Trump has just put a silly tweet, and the whole market is shaking, and everybody is going there to see the prices, and it will be slow, the server to respond. So you don't want your code to be blocking. So this is definitely any call you do over the web, it should be asynchronous call. So you should create a suspend function to do that work. So in here, what I'm doing, I am simulating the network. Later on, I'll show you a real implementation, but this is just an example. Simulating the network. So this is a function. What it will do, it will go ahead. Let me run it just to show you what's going on. When I run this function, no, not this one, I mean this here, run. Where is the result? Okay. Yeah, I think I need to stop this. Okay, let me run. Yep. Okay, let me just run it again. No parallel. Yep. What's going on here? Oh, okay, yeah, because I put cancel job. Sorry, I jumped here. Because remember, jobs are cancelable. That's why I was only seeing the first function. The second one was canceled. Okay, let me just comment this. Let me rerun this. What's going on? Okay, just a second. Yep, now it's okay. No? Yes. You can see here what's happening. Let me just run it now one more time. Not sure what that 50 is. So here what is happening is basically it's saying, oh yeah, sorry, this 50 I was surprised. Okay, let me just run it. So you see the first function will say, okay, I'm going to get this, then it's suspended, then it gave me the results, then the second function came ahead, it displays this suspended and gets me the results. So what I mean here, these two functions are suspend functions, so they do a bit of work, suspend for 2000 milliseconds, and then they come back and continue the work. Same thing for this function. So suspend function, in a simple way, a suspend function is a function that is able to suspend and resume. You do a bit of work, suspend when there is a long running task, and then resume later on. So for example, it make a call to the network to get the stock symbol. While that call is ongoing remotely, this function will suspend. And then when the results come back through the network, this function will resume. But when it resumes, it will resume here, where it first stopped, where it was last left off. So same analogy as I said before, as reading the book. So you read the book, and there is something urgent that you need to do. You basically put your bookmark, go ahead and do other things, and then resume later on reading your book. Now, once you have these suspend functions, you cannot just come and call them directly from anywhere you wish. You can just come, for example, and get this function here. You cannot just get this function and call it. So the compiler will tell you suspend function get stock symbol should be called only from a coroutine or from another suspend function. So the suspend function are the building blocks, but we cannot just call them from anywhere we wish. We must call them from within a coroutine, as it's stated in here. So how do I create a coroutine? So to be able to create a coroutine, I basically need to create what is known as a scope. So from a scope, I go ahead and launch the coroutine. Why do we need this concept of a scope? Is basically when I run these functions here, I can keep track of them and I can cancel them if I need to. So if the compiler allow you to just go ahead and write a function, call the function like this, how can you cancel it if it is running like this? It needs to be running inside some container, which is in this case a scope, a global scope, and then you use this global scope to launch these suspending functions, and then if need be you can cancel. I will explain a concrete example shortly, but let's first discuss a little bit this scope here, this global scope. So Android comes with a couple of scopes that you can use to launch coroutines. So coroutines, for you to launch a coroutine, you need a coroutine scope. And basically, Android comes with these two very important coroutine scopes already built in. You just go to them and say view model scope dot launch, and inside there you can put your functions. So if you are in a view model, you use a view model scope dot launch. If you are in an activity or fragment, you use lifecycle scope dot launch. If you are not in any of these, you may use global scope. Okay, so let me show you first this view model scope. So if you are in a view model, you can go to view model scope.launch, and inside this view model scope.launch, you can basically put in here asynchronous call suspend functions inside this. And in here, what you can do also, you can put this inside a job. You can assign this to a job, and later, if the user wants, you can basically cancel the job anytime you wish. And that's the reason we put call-in suspend functions inside the scope, is to be able to cancel them, to keep track of them and cancel them. And also, if something goes wrong with one of the functions, you may want to cancel the whole job, or other children of the job, you might want to cancel it. So if you don't put it inside scope, there is no way for you to cancel. So that's the reason why coroutines or suspend functions can only run within scope. Okay, so you have, and another advantage of scope, by the way, another advantage is that if you launch something long running and the user and this view model is destroyed, this long running task will be automatically cancelled. That's another advantage of this. Remember, as I explained in here, if the user was working on a screen and in their work, they triggered some long running task. We started the long running task, but unfortunately, or fortunately, it doesn't matter, the user decided to close that screen. So what happened is we must cancel this work. Otherwise, this work will be waste of memory, waste of battery, waste of bandwidth, and the user will not need it because they already closed the screen that they were at. So we need some way to cancel this long-running task. So normal function, we cannot just cancel it. There is no way to cancel just a normal function. That's why they invented this concept of a scope, to be able to run suspended functions inside the scope and then you can cancel them anytime you wish. So let me show you now a concrete example of canceling some ongoing task, ongoing work. So let me go to my app here and run it. And this app is running along, it has some suspended function. Let me show it to you. So I have this suspend function. You see here it's marked as a suspend. And I want to run it in the default thread. By the way, in Android we have many pre-configured threads. There is the main, there is of course the main one, the main thread. This is mainly to update the UI. There is another thread which is the default thread. This is to be used for heavy computation, for CPU intensive computation. And there is an IO thread which should be used for input output, like interacting via the network, reading something or getting something via the network, or reading something from a database or a file. So in this case, I'm just doing some computation here, heavy computation. So I want to run it inside the default thread. So take a look at this power of suspend functions. I can choose which thread to run this on. I want to run this work forever. I want to run this work forever in the default thread, which is used for CPU intensive tasks. But whenever I generate a new value, this is, by the way, Fibonacci sequence, which Fibonacci is a sequence that starts from 0, 1, then 1. Basically, 1 is the sum of 0 and 1, 2, which is the sum of 1 and 1. So f of n is fn minus 2 plus fn minus 1. So for example, 5 is the sum of 3 plus 2. The next value in the sequence will be what? The next value in the sequence will be 8. So 5 plus 3 is 8. So whenever I generate a new value, I want to notify the main thread. So I can switch to the main thread. You can see here with this simple function with context, I can switch the main thread to report the result. You remember, as I explained before, in a long-running task, I need two things, very, very important. I want to run the heavy task on the background thread, but at the same time, I want to be able to pass some data back to the main thread. The other thing I want to be able to do is to be able to cancel this long-running task whenever I wish. So this is how this is achieved using suspend functions. With suspend function, I am able to select which thread to run on. And when I have something to report to the UI, I basically switch to the main thread and then switch back to the background thread. Very powerful. To do this using threads yourself, it's a big task. It's basically very, very complex to do it right. As you will see later on in operating system course, communication between threads is not that easy, but in here, they simplify it significantly. Now here is the start. When the user asks me to start generating Fibonacci sequence, first I stop if there is an existing sequence that is running, and then I start new one by going to the view scope and launching this suspend function. So this suspend function cannot be executed from a normal function. I cannot run this from a normal function. I need to run it within a scope. Why do I need to run it within a scope? To be able to cancel it later. So I hope it's clear. So let me show you. So in here, this is my Fibonacci. I start the sequence. So you can see here what the sequence is doing. Sequence generator is doing. Generating one sequence, suspending for 4 seconds, and then going back and generating another value of the sequence. And that's what you see here. Every 4 seconds, I get a new value. And it's suspending and resuming, suspending and resuming. The user don't want any more sequences. Stop the Fibonacci. Immediately, this gets cancelled. So you can see here how coroutines helped us to have suspend and resume, the ability to suspend and resume, the ability to choose the thread on which we want to run the computation, the ability to easily go back to the main thread to report the results, the ability to easily track a particular long-running task and be able to cancel it. All this thanks to coroutines and the suspend functions. So I hope this is clear. Let me show you one more thing you can do with this powerful thing. You can also run things in parallel. So let's say I have 2 network calls. Can you see here 2 network calls? One suspend for 2 seconds and another one suspends for 3 seconds. And these are independent from each other. So why should I run them sequentially? I can run them in parallel. Why should I run them in parallel? Any idea? What is the advantage of running them in parallel?
It's faster
Uh,
than
Much faster.
sequential.
Thank you very much. It's much faster. So how do I run things in parallel? All I need to do is basically I use this async function. Async. This is an async launch function, and I call the method, and do another async and call this method. Now these 2 methods are being called async in parallel. And then once I call them, I can wait for the results. I use the async to call and await to collect the result. I use async to call and await to collect the result. And let me just run this and I will show you. You see this one is supposed to run for 2 milliseconds, 2000 milliseconds. And this one, let's make it also 2000 milliseconds. So if they run sequentially, how long it will take? Around 4000 milliseconds. But if we run them in parallel, thanks to this, it will take roughly around 4000 milliseconds with a little bit extra for this extra work to be done. So let me just stop my app here and run this. So when I run using async and await, basically, let me clear. You see here, it took basically 2,290 seconds. Because remember, this is also doing lots of things. It's printing, it's doing things. But imagine if I don't do it, if I do it like this. Let me now do launch. Just do launch. And basically in launch, I don't wait. There's no wait here. And let me just, I basically block and get the results. Basically suspend and resume to get the results. Then suspend and resume to get the results. This is result 2. And then basically display the results. Now, when I run this, because now I didn't use async and await, if I run this, this will increase. It will be almost double this. It will be 4000 something. So run this. So with coroutines, you can also run suspend functions in. You can run suspend function. Okay, it run them in. Yeah, it's still a random in parallel in this case. Okay, it's still a random in parallel. Okay, let me because this coroutine by default, I think it runs things in parallel. So let me just, sorry, just a second. Let me copy this. And let me basically run it in here. This definitely will not run them in parallel. So let's see. This will run sequentially, one after the other. What's going on here? Call duration. Ah, yes, of course, I need to do this inside here. No, just a second, try. I'll do this stuff and print. Okay, just a second. All right, let me just launch. Interesting. Okay, just a second. Job val job equal this job.join. Okay, execution time. Surprising why it is so fast. So in here, 30 milliseconds. Ah, yes, of course. Yeah, of course, I did not measure the time. Did I? Oh, I did. Launch this and then launch this. I'm not sure why. This is 2000 milliseconds. This one 2000 milliseconds. Okay. Yes. Maybe I should put this outside here to measure the whole time. Okay, let me try it. Hopefully now it should be okay. Yeah, still interesting. It is still running parallel. Okay, just a second. Just a second. So I'll basically do this work. Okay, maybe now it makes sense. So I do some suspending, then come back and display the results. Then go ahead, do the work, and come back and display the results. Okay, let me try it. Anyway, I'll have to stop it at here. So basically, let me just summarize, although I couldn't demonstrate it nicely. I confused myself. So for launch, supposed to when we call this when we call these suspend functions, they are done one after the other sequentially. And for if you want to do it in parallel, you do async and await. But unfortunately, I didn't demonstrate it nicely. So inshallah, next time I will work on this example further to illustrate it. Now, I wasted a bit of time. Now we are a bit behind. Let me just show you now a concrete example of where these coroutines could be used in a real application. So if you remember our country explorer, if you remember our country explorer, from where did we read the data that is we display in the recycler view? Do you remember from where do we read it?
From JSON file.
From a JSON file that is locally on the app, on the mobile device. But in real life, nobody will do that because information keeps changing. So you don't want to hard code the information inside your app. Instead, you could use a service such as this service here. This is an online service that can easily give you details about all countries of the world. You can either pass all as a parameter and it will return you all the countries, or you can pass particular country as a parameter under another URL, which is name/Qatar, and it will give you the details of that particular country. Now, what's going on here, this will be more illustrated better using this tool called Postman. What this tool allows me to do, it will show me concretely how this is working. So basically, when I went here and put the URL and typed enter, what the browser really did, it sent a GET request to this URL. And then it sends this request and get the results in JSON format. As you will see shortly, the JSON will come back. Here is the results with all the details of countries. And if I want to get a particular country, I change the URL, which is, for example, here name / Australia, and then send. This will make another web request and give me the details of the country. Now, HTTP is a protocol of communication. As you can see here, this is HTTP, is a protocol of communication between the client, which is this Postman, and the server. And HTTP has verbs. These are the most common verbs: get, to read from the web, post, and put. Post is to create some new resource, some new thing on the web, and put is to delete, update, and delete is to delete something from the web at this particular address. So how can we do this programmatically from our app? How can we go programmatically to the web and fetch this information and make use of it from our Android app? So the way we can do it is very, very easily using a very popular library that is called Retrofit. So you need to add a reference to this library. called retrofit. Here it is. This is a reference you add. And then there are two steps you need to do, two simple steps. The first step is you describe the service that you're trying to access. So in this scenario, you're saying, okay, I want to access a service that is available at a particular URL. If I go to all, it will return me all the countries. So what you do, you basically create a function. This is just an interface, it's just a signature of the function. So this service, in abstract way, allows me to make a GET request to this sub URL /all, and this will return me a list of countries. So this is basically describing what the service is able to do for you. In here, it's able to, if I go to this URL, /name and give it the parameter, this is a parameter, /Qatar is a really parameter. So I take this parameter and pass it as a, take this value and pass it as a parameter to the service, and this will return me one particular country, not all countries. And also I can use post to basically add a new country, for example. So in this interface, what you do is you describe the service, and for each method you annotate it. You say this method corresponds to a GET request to this URL, and this GET method corresponds to this method corresponds to GET request going to this particular URL. So once you create an interface describing the service, then the next step is you use retrofit, which is a library that you download and use, and you ask it, please go ahead and create for me some class to allow me to call this service remotely. And when you call, the methods that will be generated is exactly the same as if you did it from here. So if you call get countries, it will run this. It will run a GET request to this URL. If you do /get country and you pass /name/ a particular country, if you do get country between parentheses Australia, then it will return to you this particular country that you have specified in here. This is a parameter to this URL. And then that's it. Once you do this, two steps. One, you define the service interface. Then you use retrofit to build a class to enable you to interact with that service. And then the final step, you go to your view model. You go to your view model and say, make a call to repository.country service. This is the auto-generated class that get countries. And this will return you a list of countries, and you return them, and you make them available as a live data. Whenever this list changes, you can subscribe to this live data, and then you can update the UI. So basically what you see here is a recycler view being populated by the data coming from this URL here. So the data is really coming from here. So you can see, I think if I go a bit up here, and you can see here the population. Okay, the population here, it says 769. The area, do we see the area here? No, just the population. So the population, do we have here? Population. It's basically 24 million something. So if I look here, yes, 24.1 million. Okay, so basically the data is really coming from the web. So just to summarize, sorry I took a bit long. So underneath, this is using coroutines to do this fetching from this remote web service. So let me just summarize quickly. You will practice this in the next lab, definitely. You will practice it, you will come back next session, I will go through this again and explain it in much more details. So 3 steps. You create an interface that describes the methods provided by the remote service. You map each method, you map it to a verb, HTTP verb, and a URL. So this method is as if when I call this method, it will be exactly the same as running this remote call to this URL. /all, sorry, I need to put here /all. It will be exactly the same as /all here. And if I call it if I say get country, is exactly the same as calling this. So it's get, this is get. So get that you see here this is the get, and this is the URL. This is the base URL. This is the URL of the server plus this. So that one is basically name. And the last part is really a parameter that I pass to the function. So the parameter will be, let's say, and I can run it this way. So when I call a function get country and pass it, let's say Morocco as a parameter, this function will go ahead and make a remote service call and return the details of this particular country. And the last one is for adding as post. So as if I choose post, and this will go to /countries, and the body, the country that I pass as a parameter, will be passed as a body in here. So I can basically paste it in here, paste the country details in here, send, and it will be added. Okay, that's basically the idea. You just do this, you don't implement it yourself. You get retrofit to do the hard work and generate some code for you to call this service. So this is how it gets generated. Using this simple one, retrofit build for me a class to be able to interact with this service. This is the URL, the base URL. This is I will be using Kotlin serialization to serialize an object to JSON and vice versa, and create for me a class that has the same methods as this interface. That's it. This will create a class, and then you can call the methods in this class. So from here, from your view model, you can call the methods in this class. So you can either say .get countries or get particular country, such as Qatar here, for example. But this will be returning only one country. So what I can do, this is returning only one country. So I need maybe to put it in a list of maybe put it like this, and this will return a list of countries. So if I run this, you will see now there will be only one country in the grid, in the recycler view. So that's basically the idea. I know there is a lot of things going on here. Hopefully you get a glimpse of what coroutines are, what is their real usage in a real application. And as I explained, this is just an introduction. You will go and practice this in your lab. Come back next session, inshallah, and everything will be very clear. Any gaps remaining, I will address them, and everything you will be able to use this stuff. So definitely there is some problem. So don't worry about it. I hope you get the idea. So let's break for 10 minutes and I will be available for office hour in 10 minutes in the office hour channel. Thank you very much, and